Hi everyone. In today's video, I will be graphing all 15 problems on this sheet. My goal is to hopefully get these down to about 5-ish minutes, definitely not 10, more than 10 per problem, but we'll see. As we go through these, remember the information you're supposed to find. The amplitude or stretch, it's amplitude if we're in cosecant or secant, stretch if we're in tangent or cotangent, because tangent and cotangent, they go on forever when they go up, so there's no height. Period, interval, vertical shift, phase shift, then you graph it, and then identify the domain and range. So the usual information you have to find for these problems. I'm going to be doing each graph on one of these half sheets of paper. All right, number 1. Y equals 3 secant x plus 2. So first we fill out our info. So it's secant, so this is amplitude. Our amplitude is 3. And remember, amplitude is always positive. Next, we need to find the period. For this in particular, period is 2 pi over b. Secant and cosecant, it's 2 pi over b. Tangent, cotangent, it is pi over b. And in this problem, you always look in front of the x first. If there's no number there, it's a 1. Then look in front of the parenthesis. It's a 1 in both places, so b equals 1 here. So b is 1, so we have 2 pi over 1, which is just 2 pi. Interval. Interval is your period over 4, so 2 pi over 4. Reduce it, it's pi over 2. Next, I'm going to go out of order from the sheet. I always put my phase shift first. Phase shift, you set the parentheses equal to 0, x equals 0, we have no phase shift. So you can write that or none, whatever works for you. Vertical shift. At the end here, we have a plus 2, so we go up 2. Domain and range. Now remember, these graphs, tangent, cotangent, the range is always the infinities, but secant and cosecant, domain and range are different for every graph, so you have to graph it first before you can answer these questions. All right, we have found what we can at this point, so now we just need to graph. Okay, there's no phase shift, so 4 to the right and left is going to be a safe bet here. It's the vertical shift I have to worry about. Since I'm shifting up 2, I'm not going to go that far down here. Okay, so 4 to the right and left. And then I'm leaving some just in case I need it. All right, your interval is pi over 2. So we got 1 pi over 2. 2 pi over 2 is just pi. 3 pi over 2. 4 pi over 2 is 2 pi. Again, if you need to write these down more towards the bottom and reduce up here, you can do that. Negatives. And then we're going up 2 for our vertical shift. No phase shift, so our starting point is going to be right here. And then our amplitude is 3, so I'll need to be able to go up and down 3. So I'll need 3 more above. So I'll go up to 5. And then just taking ahead, I'll go up 3 and down 3. So we got 1, 2, 3. I need 1 more down here. You are welcome to fill in more values if need be, if you'd like to, but that is all that will be required for this graph. Okay, so phase shift and vertical shift lines, you are welcome to draw them in or leave them out. It's whatever works for you personally. I like to draw them in while I'm teaching still, of course. But again, at this point in the game, I would be comfortable with leaving them out. That's just me. but I don't think they hurt, especially since the vertical shift is also the midline. It helps us center ourselves in our graph. So this is our vertical shift of +2. It goes through 2 like it's supposed to. All right, from here we can start plotting our points. Now you got to pay attention. Secant is cosine. So we're going to plot this like it's cosine. Sorry, I dropped my pen. Okay, so we're plotting it like it's cosine. So if this is our new origin, we moved it up 2. Cosine starts at the maximum, so I need to go up 3. My first point is going to go here. Next interval, it goes down to the midline. This is where drawing that vertical shift actually is very much comes in handy. Next interval, we go down to our minimum, so we need to go down 3. And then now I can just go back up. So midline, and then maximum here. And then I'm going to go the other direction. So we're at a max still, so we're going to go down to the midline again, going to the left. Minimum, midline, maximum. So there are my points. Next thing, I find it helpful to go ahead and draw on the asymptotes to help me figure out my boundaries. So all the midline points get an asymptote. All the maximum points, they get U's going up. Be careful not to stretch this one too far to the left because I don't have an asymptote on the other side to kind of help create a boundary, so I'm just trying to be conservative about that here. Oh, let me do my maxes first. I like to do maxes and then mins. That's me personally. So midlines have asymptotes, maxes get up U's, and then mins get downward U's. So let's show something like that. All right, and then I just need to fill in my domain and my range. So domain, remember, goes interval or asymptote to asymptote in my intervals. Now, since I graphed out to here, I am going to go one more over to get this asymptote over here. And then I'll repeat that on the other side, so I am glad I left extra space. This was -4 pi over 2. Yeah, so this is -5 pi over 2. That's going to be my asymptote over here. And then just for show, because it would go down to the midline there. So that would be that. Okay. So domain, I did not leave myself much space out. I might have to scribble this out. We'll see. Start at the leftmost asymptote. So that's -5 pi over 2 for me. To the next asymptote, which is -3 pi over 2. I will definitely, you know what, it's going to bother me to write this out like this. I'm going to move these both down. That'll make me feel better. Okay, let's restart the domain. -5 pi over 2 to -3 pi over 2. In parentheses to not include the asymptotes. Union. So we started at this asymptote, ended at this asymptote. And then we're going to pick back up at this asymptote. So pick back up at -3 pi over 2 and go to -pi over 2. And then we're going to pick back up after the union at -pi over 2. And then go to the next asymptote, pi over 2. Union, pick back up at pi over 2. And go to 3 pi over 2. Union, I will go one more since I did graph this here. In a test scenario, I wouldn't be super picky about this, honestly. So you have quite a few intervals already without this extra one. This is going to be 5 pi over 2. So my last interval is 3 pi over 2 to 5 pi over 2. So there's my domain. And then the range. Range, let's focus on these min graphs here to help us get started because we should go from bottom to top. So these are pointing down towards negative infinity. So we're going to start at negative infinity. And we go all the way up to our minimum value, which is -1. And then since these are solid points, I'm actually going to use a bracket here. Reminder, we are not going to be strict on that on the test. If you do parentheses, it's still correct. Union. Reminder, everything from above this min to under this maximum here, this is technically not included in the graph. All these extra points are to help me make the graph. So the only part of the graph, honestly, that's truly part of it are the U's. That's the graph there. So everything in here is not included. So we're going to jump up to our maximum at 5, which is also included because of the solid points, and then go on to infinity. So again, there's a formula approach to this if you want to use that. Negative infinity to your minimum, union, maximum to positive infinity, if you want to think about it that way. All right, that was 1. Number 2. Y equals cosecant x plus 3. First, we need our info. First, we need our amplitude. That's a 1 in front, so it's 1. Period. Once again, sine, cosine, so therefore cosecant and secant, use 2 pi over b. Once again, look in front of the x, it's a 1, and there's not another number outside the parentheses. So once again, b is 1, so our period is still 2 pi. Your interval, 2 pi over 4, so again, it's pi over 2, just like last time. Interval, and then I believe phase shift is next. Phase shift, x equals 0. Once again, we don't have one. Vertical shift. Plus 3 at the end, so we go up 3. There's all my info, and then again, I will leave room for domain and range at the very bottom. Once again, secant, cosecant, you got to make the graph first before you fill these in. All right, let's make a graph. Once again, no phase shift, so 4 to the right and 4 to the left is safe. And we do have a vertical shift of up 3, so I am going to need quite a bit of space above my y, or on the upper part of the y-axis. So we have our 4 intervals, pi over 2, pi, 3 pi over 2, 2 pi, set up the exact same way as the previous problem. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then we're going up 3, so I'll need up to 3 for sure. And then my amplitude is only 1, so I'm going to go up 1 more. So I'll be bouncing between 2 and 4 when I make my points. Okay, so vertical shift of up 3, no phase shift, so this is going to be my new origin. My new midline is going to be through 3. And again, that represents my midline and my vertical shift of plus 3. Now my points. This is cosecant. Cosecant is like sine. So I start on the origin. That's where sine starts. So that's my first point. And then regular sine, natural sine goes up after the first point. So my next interval, I'm going to go up by my amplitude, which is 1. So I'm going to put my first point at 4, my next point at 4. So we go up, here's our maximum, back down to the midline, and then down to create our minimum, and it's again only 1. So I'm going to go down to 2. Back up to the minimum, or not the minimum, the midline for my last point here. Yep. And then repeat to the other side. So again, we're at the midline on the origin. We went up to the right, so we're going to go down to the left to create our minimum, midline, maximum, midline. There are my points. All right, filling in the extra stuff. Asymptotes through the midline points. And then upward U's are my maximums. And downward U's are my minimums. And there's our graph. All right, domain and range. Domain, we jump from asymptote to asymptote and make our intervals. It looks like I'm going to have 4 intervals here. So we have negative 2 pi to negative pi, all in parentheses because they're asymptotes. Union, pick back up at negative pi to 0, union 0 to pi, and union pi to 2 pi. Range. If you remember the formula approach, if you want to do it that way, it's negative infinity up to your minimum value, which is 2. 2 gets a bracket because it is included. It's a solid point. Union. We jump up to our maximum, which is at 4. Also gets a bracket. And then we continue on to positive infinity. And there's our graph. Number 3. Y equals tangent of 2x plus 1. Info. This time A is not amplitude, it is stretch. So we're kind of shifting some things in our mindset as we're going into a tangent graph. So this is stretch. Our stretches are A value still, so A equals 1. Next is the period. Here's another change. Period for tangent is pi over b, not 2 pi over b. Pi over b, go to the x. We do have a number in front of it. It's 2, so it's pi over 2. Interval. Come on, focus. There we go. Interval is your period divided by 4. I'm going to do this on a separate sticky note. Actually, you know what? I've got the space. I'll do it under here. So pi over 2 divided by 4. You can do a couple tricks here. One trick is to multiply the denominators, pi over 8. I'd be careful though, because depending on the context, it doesn't necessarily always work. You could also do keep, change, flip, full out. Pi over 2 divided by 4. That becomes pi over 2. Keep this the same, change this 2 times. And then this is like 4 over 1, so you flip it, 1 over 4. And then when you multiply straight across, you're going to get pi over 8, which is what I got over here. Pi over 8. Or another thing, just remember fractions, when you get larger denominators, you're actually making it smaller. So it makes sense that you would end up with an 8, because these are much smaller intervals than a pi over 2 would be. Okay. Phase shift is next. Phase shift, you set the parentheses equal to 0. So we have 2x plus 1 equals 0. Subtract 1, we have 2x equals negative 1. Divide by 2, x equals negative a half. Hold up. Oh, I completely wrote that wrong. Sorry. This is 2x plus 1. Okay, hold up. That was wrong. I was like, that is weird. We haven't done one of those. Okay, 2x, just the 2x. So let me change that. 2x equals 0. Well, that's much nicer. If I divide both sides by 2, x is still 0. So none. We do not have a phase shift. Okay, one parenthesis changes everything. We've talked about that before. Vertical shift is a plus 1, so we go up 1. No phase shift, but we do have a vertical shift. All right, now we can graph. Now tangent, if we remember the general shape, I'm not going to draw my y-axis yet because I'm trying to figure out how much space I need. Tangent sits on the middle of that, so on the origin itself. So we will need, I'm going to need 6 points to the right and the left. This will make more sense once I've drawn this. So let me think about this. 6, 5, 4, 3, 2, 1. Yeah. So this is where I want to place my y-axis. Well, actually, now I've got plenty of space. Okay. I definitely played it safe there. We're good. I'll re-explain that again in a moment once I get some points graphed. And once I get this fully graphed, I'll again re-explain how I knew what the intervals were going to look like. Okay. So our intervals are pi over 8. So we've got 1 pi over 8. 2 pi over 8 is pi over 4. 3 pi over 8. 4 pi over 8 is pi over 2. 5 pi over 8. And then 6 pi over 8 is 3 pi over 4. Yes. And then the negatives. Okay, we've got a vertical shift of plus 1. So this will be our new origin. And this will be our new midline. It's a vertical shift of plus 1. Okay. My stretch this time is 1, so I only need to go up 1 more on the y-axis. You're welcome to graph more if you'd like. Okay, I have everything I need to start graphing. So, for these problems, you have to be aware of the general shape of the tangent graph. So, reminder, tangent is disco right. Its middle point, so you have 3 points you're going to graph. The middle one that sits on the midline starts at the origin, and then you'll graph up to the right with an asymptote, and then down to the left with an asymptote. So that's our general shape that we're looking for here. So my first point is going to go in the middle here. I'm going to go over 1 interval and then up by my stretch, by my A, which was 1. So I go up 1. And then this next value is going to have an asymptote. And then going to the left, I'm going to go 1 interval to the left and then go down 1. So that's going to put me on the x-axis to get my disco right shape mapped out. And then my next interval over will have an asymptote. And there is 1 tangent full period graphed, 1 tangent curve. Now how I knew how many intervals to do here, I knew that with tangent being at the center of it being on the origin, it took up 2 intervals to the right and 2 to the left. So if I want 1 more full period, I needed 4 more values. So I went 4 right and 4 left. Now remember, you only need 2 periods, so you can either repeat this whole thing to the right side or the left side. It really doesn't matter. I think at this point, I've just got more space over here, so I'm going to go over here for my graph, but if you go to the right, it's still correct. So from here, it's literally a mirror image. So I've got my right asymptote here. Not even mirror, it's literally copy-paste. That's a better way to put it. So my first point, if I go to the left, is going to be the point going up. So up here at 2. The next interval is that point in the middle. The next interval is that point down 1, which is on the midline. And then that next interval to the left is my asymptote. And I got my disco right shape. There's my completed graph. 2 periods, asymptote to asymptote. Domain and range. Now remember, range on this one is the infinities because it stretches down and up forever, no breaks on our vertically speaking. So domain works just like the secant and cosecant graphs. You would go interval by interval, so asymptote to asymptote, and I've only got 2 sets, so I'm going to have 2 intervals here. Negative 3 pi over 4 to negative pi over 4. Union, pick back up at negative pi over 4, and then I go to positive pi over 4. And that's where I stopped because that's all I graphed. All right, next problem. Sorry, I got a lot of different papers over here. I'm shifting through. Okay. Number 4. Y equals 2 cotangent 3x. I'm going to pay more attention to my parentheses this time. Minus 4. So again, fill out the info. Again, cotangent, tangent, you use stretch, not amplitude, so this is called the stretch. It's your A value, A is 2. And then the period. Reminder on these, the period is pi over b. This time, b, with the number in front of x, is a 3, so it's pi over 3. So our interval, pi over 3 over 4. I'm going to do the trick where I just multiply these together, so I'm going to get pi over 12. If you want to do keep, change, flip, that's fine. It will get you the same answer. Because it's basically pi over 3 times a 4th, pi over 12. All right, phase shift. Once again, we have just a number like 3x inside the parentheses. 3x equals 0, well, that's going to give us x equals 0. So once again, no phase shift. Vertical shift. Negative 4, this time we're going down, so I need to keep that in mind when I make my graph. Domain and range, I will write down when I'm done graphing. Since I know my vertical shift is going to go down 4, I'm going to kind of graph or draw my x-axis up higher to accommodate for that. And then no phase shift still. This is cotangent, so I can very comfortably just do 4 to the right and the left, and it'll work in my favor. That's because cotangent's asymptote sits on the origin. That's very easy to work with. Okay. So 4 intervals to the right, 4 to the left. Period is pi over 3. Sorry, interval is pi over 12. Got to be careful there. 1 pi over 12, 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. Yeesh, that was a lot of reducing. I'm going to write those out just in case anyone needs it. So that was pi over 12. This was 2 pi over 12. This was 3 pi over 12. And then 4 pi over 12. So that's how these reduced down when I wrote them out. Okay, and then the negatives. Negative pi over 12, negative pi over 6, negative pi over 4, negative pi over 3. So there are my intervals, and then my vertical shift is down 4, still no phase shift here. So I go 1, 2, 3, 4. Here's my new origin and my new midline. Vertical shift down 4. Alrighty. From here, I need to think about where my points are going to go. This is a stretch of 2, so I'm going to go up 2 and down 2 when I make my graph. So I'll need 2 more under it. So we've got negative 1, negative 2, 3, 4, 5, and 6. So those are all the values that I need. You're welcome to add more beyond that if you feel like it. Okay, starting our graph. Now remember, general shape, you have to know what it looks like. Cotangent is a disco left shape, so it goes up to the left, down to the right. And then its starting point is on the origin with an asymptote. So we've got it starts at the beginning instead of in the middle like tangent. That's how I knew I could just go 4 right and 4 left, and I'd have space. So I'm going to start with an asymptote and graph my up point, midline point, down point, asymptote. All right. So asymptote first and foremost on my origin. And then if it helps to graph the midline point first, you're welcome to do that. I like to do that personally. It helps me center myself. So I go over 2 intervals to do that. Here's my midline point, and then disco left, so I go up to the left. So if I go left, and then I go up 2, because that's my amplitude, that's my stretch. So I'm going to go up to here. And then when I go right, I go down 2. And then my next interval, that doesn't line up as nicely as I'd like it. Let me kind of make that, there we go, something like that. And then my 4th interval to the right is another asymptote. And then connect them. I have the hardest time drawing disco left. I don't understand why. That looks better. Okay, so this is a full period. I need 2 full periods for this to be complete. So clearly I made the space for that to the left side. So I'm going to repeat this pattern. So I've got my asymptote here. I'm going to go left 2 to get my midline point. Okay, so to the right it goes down. Down 2. I'm going to graph that point again. And then we go up 2. So I'm going to copy this point over here. And then this will be an asymptote. Remember, once you get your first graph, your first period graphed, it's basically copy paste. I wish I would have curved that a little bit more. It's fine. Something like that. Okay, there's my cotangent graph. Disco left shape. Asymptotes on the origin. Now we just need domain and range. Remember, range is easy on tangent, cotangent. It is just the infinities. No breaks, vertically speaking. Domain, we go interval to interval, or asymptote to asymptote. So I'll have 2 intervals here. Negative pi over 3 to 0, union 0 to positive pi over 3. And that's all I can do. All right, that is my graph. That was number 4. Number 5, y equals -3 tangent of 4x minus 2. Info. Once again, we got tangent, so this is a stretch. A is, now we have a -3. Remember, A is still positive because your amplitude and your stretch are always positive. A can be negative. So when you're filling this in, make sure it is the absolute value of A. So I'm not going to write -3, I'm going to write +3, but I am going to write reflection next to it. So I remember that I reflect when I graph my points. Okay, so we got a stretch, and then our period. Once again, tangent is pi over b, not 2 pi over b. B, you look in front of the x, and it's a 4, so it's pi over 4. Interval, pi over 4 over 4. It's this times 1/4, or 4 times 4 is 16. So pi over 16. Next is phase shift. Once again, we have just a number with x in front of the x inside. So again, if we solve, we're going to get x equals 0. No phase shift still. Vertical shift. -2 down 2. All right, let's graph. This is tangent. No phase shift, so we're still starting on the y-axis. So I'm going to do what I did before. You can do 6 intervals to the right and the left to make sure you have room for 2 full periods, but you won't use all of that space. So if you want to cut back a little bit, that's fine. Okay, and we have a vertical shift of -2, so I'm going to start a little higher. Okay. So a little closer than I'd like it to be. Okay. If you decide ahead of time which side you want to graph the extra tangent function on, like if I want to graph on the right side, then I only need to go left 2 on this side, for example, because I'm already kind of visually mapping this out in my head. But again, if you kind of struggle with that part, just give yourself a lot of extra space and you'll be fine. Okay. Our intervals are pi over 16. So we've got 1 pi over 16. And then we've got 2 pi over 16. That reduces down to pi over 8. And then 3 pi over 16. 4 pi over 16, that's pi over 4. 5 pi over 16. And then we've got 6 pi over 16. That's going to be 3 pi over 8. Yeah, looks good to me. And then the negatives. All right, and then the vertical, the y-axis. We have a vertical shift of -2, so I need to go down 2. So this is my new origin because we have no phase shift. This is, I'm going to put that now. New midline. All right, and then let's think about how many more values I need. A is 3, so I'm going to go up 3, 1, 2, 3, so I need a 1 up here, and then down 3, so I'm going to go down to -5. And that's all the stuff I need. Again, you're welcome to add more if you'd like. Okay, so the actual graph. Tangent starts on the origin. Now, a reflection is not going to change that. Now, you can try and like really think about it if you want. Tangent's supposed to go disco right. So you can think about, okay, if I go up so I go up to the right, I go up my 3 and then I reflect it, you can do that. Remember, when you make it a negative, all it does is it changes the shape to disco left. So you can do it that way if you want. It's going to make it a lot easier mentally. Just think, oh, okay, instead of disco right like I'm supposed to, I'm going to graph disco left. Got it. So that's what I'm going to do. So disco left, I go up to the left. So I'm going to go left 1 interval and up my 3. 1, 2, 3. And I'm going to go right and I'm going to go down my 3, down to that -5. So I'm going to have a disco left shape. And then asymptotes to the left and right of that. So it basically just looks like a cotangent function that has a tangent starting point, is kind of what we have here. Okay, I need one more. So again, you could go to the right or the left. I'm going to go to the left since I've got more space. Copy, paste. So I'm going to copy over that -5 point first. And then next point is my midline point. So that was the -3 pi over 16. So negative pi over 4 gets the midline. -5 pi over 16 gets that up point, and then the next interval gets the asymptote. You guys will have actual grid squares provided to you on the test, so locating points is going to be a lot easier than me kind of freehanding it over here. Something like that. Okay, I've got 2 full periods, so I can stop there. Domain and range. Range is still the infinities. Domain, asymptote to asymptote. -3 pi over 8 to negative pi over 8. Union, pick back up at negative pi over 8 and go to pi over 8. And that's it. That's my graph. That was number 5. All right, number 6. Y equals -2 secant x plus pi over 2. Now we can have a phase shift. Yay. Okay, info. Since we are back to secant, which goes with cosine, we can call this an amplitude again. And it is a -2. Now remember, the amplitude is always positive. It's the absolute value of A. So write +2 and then make a note that you have a reflection. All right, period. Flipping back to the sine cosine graphs, secant cosecant, we are back to 2 pi over b. B, let's look in front of the x. We've got a 1 here. Let's look in front of the parenthesis. It's also a 1. So it's B is 1. It's just 2 pi. Interval 2 pi over 4. I'm going to write that over here. So pi over 2. Phase shift. Set parentheses equal to 0. X plus pi over 2 equals 0. Subtract pi over 2 on both sides. X equals negative pi over 2. So that is my phase shift. Vertical shift. We have nothing added at the end there, so we don't have one. All right, let's graph. Now, phase shifts make this definitely more complicated because I need to figure out how much that's going to shift over. So usually, I do 4 to the right and left. I'm phase shifting, thank goodness I can clearly think about this. I'm going left pi over 2. And then that's only going to be one interval over. So I will just need an extra 1 to the left. So I'll need 5 to the left, 4 to the right. And technically I won't even need all that. I'll get to that in a minute. And then no vertical shift. So that's not going to be too bad on the y-axis. Reminder for these graphs, just like with the sine and cosine graphs, I said 8 points made up 2 periods. Same thing here. So if you have 8 points total, you'll get your 2 periods. That's a rule of thumb to live by. Okay. So let me set up my x values. I have an extra 1 to accommodate for that phase shift over there. So I've got pi over 2 is my interval. 2 pi over 2 is just pi. 3 pi over 2. 4 pi over 2 is just 2 pi. And then the negatives. And then one more, this is negative 5 pi over 2. Phase shift, we're going to negative pi over 2. So that's a phase shift. So my origin is now here. No vertical shift. So now we can start graphing our points. So secant, that is cosine. Oh, I didn't do my y values, hold up. Amplitude is 2, so we're going to go up 2 and down 2 from our midline, which is through the x-axis, so just a positive 2 and a negative 2. Okay, so back to where I was at. This is a reflection. I almost didn't even notice that when I was doing that. So cosine, and then cosine normally starts at positive 2 to make a maximum, goes up 2. But since it's a reflection, we are going to start at our minimum, which is down 2. Remember, an easy way to think of these is also we're reflecting over the x-axis. So that's how that works. Okay, so I'm going to graph to the right. So we're on the minimum right now, so I'm going to go up to the midline for my next interval, up to the maximum, down to the midline, down to our minimum, and then back up to our midline. Okay, and then I'm going to graph to the left now. So we're at our minimum, so I'm going to go up again to the midline, going left, maximum, midline, minimum. Now this here is graphing above and beyond the number of points, but I definitely hit my minimum number of points here. Okay. From here, we fill in the information for a secant graph. We don't connect the dots. I mean, you can lightly connect them if that helps, but don't do it darkly, please. All the midlines get asymptotes. So our midline points got asymptotes. All our maxes, so both of them, get upward U's. And then our minimums, I'll graph half of that, get downward U's. So for me personally, having half of this bothers me, so I am going to go out one more and get that other asymptote and include that in my domain. But if you wanted to do your domain starting with the negative 2 pi, go from there, I'd be fine with that. Negative 5 pi over 2, negative 6 pi over 2 would be negative 3 pi, asymptote. There we go. Now it's fixed. Okay, there's my graph, domain and range. Remember, neither one of these get both infinities, so these are both special to the graph. So domain, same thing, asymptote to asymptote. Negative 3 pi to negative 2 pi. How did I put a comma? It's a union. Union. Negative 2 pi to negative pi. Union, negative pi to 0, union, 0 to pi, and then one more union, pi to 2 pi. Just gotta double check myself real quick. Yep. Got all my intervals included. Again, make sure you include all the intervals that you decided to graph. All right, range. Remember, we go from negative infinity up to our minimum value, so negative infinity up to negative 2. Brackets, since it is included with the solid dot. Skip all this, go up to our maximum of 2, and then up to infinity. And there is my completed graph. It's number 6. Number 7. Y equals negative 4 cosecant x minus pi. Info. Cosecant, so this is still called the amplitude. Positive 4 with a reflection. Period. Once again, cosecant, use 2 pi over b. 2 pi, b is 1. If we look in front of the x, we have a 1 there, and then in front of the parenthesis, it's still a 1. So 2 pi over b is just 2 pi over 1, or 2 pi. Interval, at this point, hopefully you know 2 pi over 4 is pi over 2. Phase shift, we do have one. Set x minus pi equal to 0. Solve for x, you get x equals positive pi. And then the vertical shift. Nothing added at the end, so none. Domain and range will be handled in a moment. Phase shift of pi. Our interval is pi over 2. So if you're thinking ahead about your intervals as you're mapping them out, we have pi over 2, and then the second one is pi. So this is going to shift over 2 to the right. So I'm just thinking about that as I go into my graph. Now this one, I'm going to stick with that hard line, not hard line, but that rule of like 4 to the right and left is safe. I'm going to do that. And then it's going to, you'll see in a moment. And then no vertical shift, amplitude is 4, so keep that in mind. Gonna need quite a bit of my y-axis here. So I've got 1, 2, 3, 4. 1, 2, 3, 4. And then I'll actually need 4 here. 1, 2, 3, 4. Because I'm going up 4 and down 4, midline is still the x-axis. Okay, interval is pi over 2. 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi. And the negatives. Okay, phase shift is through pi. So this is my new origin. Phase shift. So what I'll do to make sure I get enough points, that was what I was trying to explain earlier, but I just figured it'd be easier once I have this mapped out. I'll go 2 to the right and then 6 to the left. That's still 8 points. Yes, okay. So my starting point, we have cosecant, which is sine. Now sine starts at the origin, so reflection or not, it doesn't change that point. So we start there. What it does change is that natural sine goes up after the first point. So instead of going up to 4, I'm going to go down to -4 for my first point to the right, because this is a reflection. And our amplitude is 4, so we're going down 4. And then we go up to the midline for our next point. So I went 2 to the right, so I'm going to go 6 to the left to compensate. Okay. So then we went down to the right, so I'm going to go up when I go to the left, up to 4. So amplitude is 4. Down to the midline, down to our minimum, up to our midline, up to our maximum, down to our midline. Okay, I got my 2 to the right and then 4 or 6 to the left to make my 8 additional points. So that worked out. All right, now we just map it out. Asymptotes through the midline, through the midline points. So our phase shift also turned out to be an asymptote. So it worked as both in this scenario. Doesn't always happen that way, but it is nice when it does. Okay. So there's all my midlines. They get asymptotes. My maxes go up. And my mins go down. All right. There's my completed graph. All that's left to do is domain and range. Reminder, these are special to this graph, so no negative infinity to positive infinity. Domain, asymptote to asymptote. So -2 pi to -pi. Union, -pi to 0. Union, 0 to pi, union, pi to 2 pi. Range, negative infinity up to that minimum value, which is -4. Union, skip all of this up to our maximum. Oh, and this is a bracket, if I'm going to get technical here, because that is the solid point. Jump up to our maximum, which is at +4 with a bracket, and then up to infinity. Now there is my completed graph with domain and range. Number 8, we are officially at the halfway point. Y equals -2 cotangent x plus pi over 2. Info, Cotangent, so this is called the stretch. This is 2 with a reflection. And remember, in this case, cotangent is supposed to be disco left. That means it's going to be disco right. It's an easy way to put it. Period. We are switching back to pi over b. So it's pi over, let's go up here. In front of x we have a 1. In front of the parenthesis we have a 1, so b is just 1. So pi. That makes our interval easy. Interval is pi over 4. Phase shift. We do have that. X plus pi over 2, set it equal to 0. So you will get x equals negative pi over 2. Whoa. X, not pi. Okay. X equals negative pi over 2. Vertical shift. Once again, we have none. Domain and range will come later. You could technically fill in the range right now if you wanted to. Okay, my interval is pi over 4. And then this phase shift will move me to the left 2 points. Just kind of thinking aloud here. Four to the left and the right will not work here. I'm going to need to extend one of the directions. So if I move left pi over 2, it's going to start me over here. And it's going to kind of put it in the middle. To compensate, I'm going to add 2 extra values to the right. I'll just go more to the right if that makes sense. So I'm going to need 6 to the right and 4 to the left. Again, if you're not sure, make 4 and 4 and then extend the graph as you need to. That's perfectly fine. I'm just kind of thinking ahead because my graph takes up the whole space I have here. So I'm going to have 6. And then, okay. I don't need a ton of space on my y-axis. Okay. So my intervals are pi over 4. So we have 1 pi over 4, 2 pi over 4 is pi over 2. I haven't done pi over 4, so I will write out the fractions one good time. This is 2 pi over 4. Maybe I have, I can't remember. 3 pi over 4, 4 pi over 4 is just pi. 5 pi over 4. And finally, 6 pi over 4 is 3 pi over 2. And then the negatives. Okay, so what I was saying earlier, our phase shift is negative pi over 2. So this is where my starting point is going to be. And then cotangent starts at an asymptote. So it's going to take up 4 values to the right here. So 1, 2, 3, 4 is where here it's going to end. And, sorry, 1, 2, 3, 4, here's where it's going to end. And then it picks back up and goes again to the right. Because I did not have enough space to the left for sure. I could have made more here. I do have some space. So I accommodated by adding some extra ones so I could fit another period here. So that's where my head was at earlier when I was making the values. Okay. Again, if you can't do all of that ahead of time, just make some points, but make sure you have some space to extend as needed. That just comes with time and practice. And I have to think kind of hard about it. I'm not gonna lie there. Okay, that's our phase shift. And then no vertical shift. Oh, y values. So no vertical shift, so we're on the midline. Our stretch is 2, so it's up 2 and down 2. So I'll need 2 tick marks each. Okay, now we got our points. So this is a disco right because of the reflection. So cotangent starts at the origin with an asymptote. So this is also an asymptote and a phase shift here. And then I'm going to create that center point first. So I'm going to go 2 to the right to make the center point on the midline. And then disco right instead of left. So I'm going to go up to the right. So I'm going to go to the right and up 2 to my maximum. And then to my interval to my left, I'm going to go down 2 for my minimum. And then one more interval right, I will have my asymptote. And then fill in the shape. So this is disco right. So hopefully you can see looking at it now, this is cotangent because it started at as an asymptote, but then it's reflected because it's going the wrong way. It should be going disco left, but it's actually going disco right. And then you just need another version of this copy paste. I made room over here for that. If I wanted to extend my graph to the left and do more here, I could have done that as well. Okay, so I've got my asymptote already. So my next point is going to be this one here. And then my next point is the point in the middle. And then my next point is up at my maximum. Not my maximum, my stretch. My stretch up. And then lastly, my asymptote. Okay. And there's 2 full periods. Domain and range. Range is easy, it's just the infinities. Domain, asymptote to asymptote. Negative pi over 2 to positive pi over 2. Union. Positive pi over 2 to 3 pi over 2. And there is number 8, fully completed. Number 9. Y equals 3 secant 2x plus pi plus 1. Yes, okay. Info. Secant, cosecant, we call this amplitude. And it's a positive 3, so no reflection here. Period. Once again, we are back to 2 pi over b. 2 pi over our b value, look in front of x, it's a 2. So it's just pi. Interval, well that's just pi over 4. Phase shift. Set the parentheses equal to 0 and solve. 2x plus pi equals 0. So we'll take a couple steps. Subtract pi. We get 2x equals negative pi. Divide by 2, x equals negative pi over 2. So that's my phase shift. All right, vertical shift. This time we do have one, it's plus 1. So I'll have to keep that in mind. Okay, thinking out my graph here. You know what? With the secant and cosecant, that should always work with 4 to the right and left, honestly, because of how the graph just manages to work out. So I'm just going to stick with that rule for this one. And then we're vertically shifting up 1, and then we'll have an amplitude of 3. So I'm going to need a bit of space above here. A little bit down here. Okay. 4 to the right. 4 to the left. This is much curvier than my other graphs so far. Okay. Intervals are pi over 4. 1 pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4 is just pi. Negatives. And then my y-axis, vertical shift of up 1. And then we're going to go up 3 after that. So 1, 2, 3. It's going to put us at 4. And then we'll go down 3 from 1 as well. So 1, 2, 3. I'll need to go down to -2. That is the extent of my graph. So vertical shift of up 1. So this is my new midline. And then my phase shift is through -pi/2. That's my phase shift. So where they cross, that is my new origin. So that's how I moved it. I moved it up 1 and then left pi/2. Okay, I think I'm ready to graph. So this is secant, which is cosine. Cosine starts at the maximum, no reflection here. So we are going to go up 3, which puts us at the 4. So this is my first point. And then to the right, we go down to the midline. Next interval, we go down to our minimum. So 1, 2, 3. And then we're going to go back. So we're going to go up, back to our midline for the next interval. And then up to our maximum for our next one. Down to our midline. And then down to our minimum. And then I'll just graph these two to the left and we will be done with the points. So if I start to go left, we're at a maximum here, so I go back down to the midline again. And then our last interval will be at a minimum. All right, now we fill in the rest of the details. Midline points get asymptotes. Okay. Maxes go up. So my phase shift this time was not also an asymptote, it was a maximum. And then minimums go down. This one I will draw just halfway and I'll start my domain here. Yeah. Okay. So from here, I just need my domain range. Okay, remember for secant and cosecant, these are both very different. Domain, we go asymptote to asymptote. -3 pi over 4 to -pi over 4. Union. -pi over 4 to pi over 4. And then pi over 4 to 3 pi over 4. Good. Okay, and then the range. Remember, it starts at -infinity and we go up to our minimum, which is at -2, with a bracket, union, bracket, up to our maximum, which is 4, and then up to infinity. And there is that graph, number 9. Number 10, y equals 2 tangent of 4x minus pi plus 2. Okay. info. Again, this is called the stretch when it is the tangent cotangent. A value is 2. No reflection this time. Period. Once again, we are now doing pi over b. So our b value, if we go up to our x, in front of the x we have a 4, so our b value is 4, pi over 4. So our interval is going to be pi over 16. It's pi over 16 over 4. Sorry, pi over 4. And then that's over 4. Multiply by 1/4 to do the keep change flip, you get pi over 16. Okay, interval phase shift. We do have a phase shift here. Parentheses equal to 0, 4x minus pi equals 0. Add the pi over, we get 4x equals pi. Divide by 4, x is pi over 4. Vertical shift. We have that as well. We do have a +2 at the end there, so we go up 2. So we do have both. Okay, I got to think about this one a little bit. Let's see. Period is pi over 4, and our phase shift is pi over 4. Okay, that helps. So that means we are moving right a whole period. So those 4 interval notches I usually make, we're moving a whole 4 of those over. So since tangent sits, just to give you a visual here while I'm thinking about this, since tangent sits in the middle here, it's going to sit at the end of those 4 values. I need 2 more to the right to make up for it. So that's what I'm going to do. I'm going to draw 2 extra values to the right, and then my usual 4 to the left. Vertical shift is up 2, so I'm going to need some extra space vertically as well, above the x-axis. So just some things I'm thinking of. So 6 to the right, so we're going to go 1, 2, 3, 4, 5, 6. And then our y-axis, and then just 4 over here. I probably won't even use, might use 2 of these, I'm not sure yet. But I won't use all of them, I know that. Okay. And then our vertical shift is up 2. So 1, 2, this is where our vertical shift will be. And then our stretch is 2 more, so I'm going to go up 2 more on top of that. Okay. And then I won't really need anything under here, so I don't need to go that far out. Okay. Pi over 16. I think I wrote these out in a previous problem, so I'm not going to do it here for the reducing. 1 pi over 16, 2 pi over 16 is pi over 8. 3 pi over 16. 4 pi over 16 is pi over 4, as it should be. That is the period. It's the 4th value. 5 pi over 16. And then 6 pi over 16, that's 3 pi over, that's not right, hang on. 6 pi over 16 divided by 2, that's 3 and 8. Okay, I almost put 4. I'm like, that's too big. Okay, 3 pi over 8. This is why writing out the fractions first and then reducing them can help. Okay, negatives. And then we got 1, 2, 3, 4. Our vertical shift will be up 2. So it'll be here, and then we're going to go up 2 and down 2. So I really don't need any of the negative y values. I won't graph them. Okay. Now we need to figure out where our full shift is, because we have 2 shifts here. Vertical shift is up 2. So again, this is our midline, which is also our vertical shift of +2. And then our phase shift is through pi over 4, which is here. And then where they cross is my new origin. That's my new starting point. And now I can start graphing. So tangent has a disco right, and then its starting point is the middle. So you have the 3 points that you plot, it's the middle one. That goes on the origin. So then, and disco right goes up to the right. So I'm going to go over to the right first and get that one. So if I go right one interval, I'm going to go up my stretch, which is 2. So that's going to bring me to 4. And then if I go to my left, I'm going to go down the 2 stretch values. So that's going to bring me down to the x-axis. And then if I go one more out on both sides, I'm going to have asymptotes. Okay, and draw in the disco right shape. I recommend drawing in the asymptotes before you draw in the shape. That helps you avoid hitting the asymptote. Make sure you do not go past it. And now it's just copy paste to the left. So I got my asymptote, and then I need my up point, so this is going to be at 4. Next interval is going to be at the midline. Next one's going to be down, and then my asymptote. There's my 2 tangent curves, 1 period each, 2 periods total. Domain and range. Range on this one is the infinities. Domain, we go asymptote to asymptote. Negative pi over 8 to positive pi over 8. Union. And then pi over 8 to 3 pi over 8. And that is my graph, number 10. Five left. Number 11. Y equals 4 cotangent 2 of x plus pi minus 1. Info. Cotangent, so this is called the stretch. Positive 4, no reflection. Period. Reminder, cotangent, that means it's pi over b. So let's find our b value. Go in front of the x, that's a 1. Go in front of the parentheses, we have a 2. So this is our b value here. So it's pi over 2. Interval. Pi over 2 over 4, that's pi over 8. Phase shift. Set the parentheses to 0. Just the parentheses, leave out the 2. It wouldn't change a thing if you included it. Subtract pi over, you will get x equals negative pi. Vertical shift. Minus 1 at the end. So we go down 1. Come on. There we go. There's all the info spelled out. Cotangent, I got to think about this, especially with the phase shift. Okay, our period is pi over 2, so half of a pi. So the phase shift is going to go left down to negative pi. So this is when you really got to think about in advance, because if I just graph my 4 to the right and left, I'm not even going to have negative pi on my graph. I need to go out an extra whole period to the left to get to negative pi. So you can do 4 to the right and then 8 to the left if you want. Or if you're thinking ahead about this kind of thing, I need to go 2 periods to the left. So that's all I'm going to graph. I'm not even going to graph the right side of the x-axis. Okay, and then vertical shift, I'm going to need some space for sure under. So you can kind of think about that as well. It's down 1. I go here, and then I'll extend it upward in a moment. So again, my period is pi over 2, and we're going out to pi, negative pi for a phase shift. So I need 2 periods. I need 1, 2, 3, 4, 5, 6, 7, 8. So if I put 2 periods together, I will get a full pi on top of that. If I go 8 out, that will be 8 pi over 8. That is negative pi. So I've got negative pi over 8. Negative 2 pi over 8 is pi over 4. Negative 3 pi over 8. Negative 4 pi over 8, that's pi over 2. Negative 5 pi over 8. Negative 6 pi over 8, that's negative 3 pi over 4. Did I skip one? 6? No, I need 7. 7 pi over 4. Okay, negative 8 pi over 4, which 8. 8, 8, 8. Hold on, let me back up. Okay, let me back up a little bit. Negative 3 pi over 4, and then that was the negative 6 pi over 8, negative 7 pi over 8, negative 8 pi over 8 is negative pi. So that was 2 full periods to get to my phase shift alone. So let me go ahead and write that in now. So phase shift is here. And then my vertical shift is down 1. Hate to cut through this, but here we are. Okay, so this is my new starting point. Now I'm just going to graph straight up to the right. If you can't already tell, that's what I'm going to be doing here. Okay, and then I need to fill my y values. So this is my vertical shift, my midline. Vertical shift was negative 1. My stretch is 4, so I'm going to go up 4 and down 4. So down 4, I need to go down to negative 5. And then up 4, so I'm going to need 3. Yep, okay. Now I have all my values ready. Okay, so we're starting here at our starting point. Cotangent starts with an asymptote, so this is going to be an asymptote as well as a phase shift line. Okay, and then I like to plot that middle point first, so I'm going to go 2 to the right to place that. And then this is disco left, so because it's cotangent. So it goes up to the left, down to the right. So I'm going to go plot my upward movement. Up 4, which I've already... Oh goodness, I put that in the wrong place. It's like, why is that wrong? Sorry. Asymptote, my starting point is actually here. So actually my point should be down here. I'm sorry, guys. It's like, that does not match up with what I had done. Okay, so... that is not supposed to be there. Okay, my apologies. All right, so we start here on the midline. Okay, so I'm going to go disco left, so I go up to the left. So I'm going to go up 4, 1, 2, 3, 4. I'm just going to end up at 3. This is why I plan ahead, because I catch mistakes like that if I plan ahead. Okay, now I go right and then down my 4. 1, 2, 3, 4. About there. Okay, and then this next value over here is going to have an asymptote. Okay. And then my disco curve. Disco left. And go down. There we go. And then we just copy and paste over here. So I'm going to copy this over. My next interval will be the up value. And then the midline, I almost put it on the x-axis again. And then this will be through negative 5. And then asymptote. and then disco left. Okay, 2 full periods graphed. We made it. Domain to range. Range is easy, it's the infinities. Domain, asymptote to asymptote. Negative infinity. Oh my goodness. Negative pi to negative pi over 2. Union. Negative pi over 2 to 0. Then I can stop with that because that's all I have graphed. That was number 11. Number 12. Y equals cosecant x minus pi over 4 minus 7. All right. Info. Cosecant, so we do call this the amplitude. And there's nothing there, so it's a 1. Period. Reminder that we are back to 2 pi over b. 2 pi, and then we look at the x. There's no number in front of it, so it's a 1. Outside the parenthesis, it's also a 1, so it's just 2 pi. 2 pi over 1, 2 pi. Interval, 2 pi over 4 is pi over 2. Phase shift. We do have a phase shift. X minus pi over 4 equals 0. If you add the pi over 4 over, we get x equals pi over 4. Vertical shift. Negative 7. We're definitely going to have to accommodate for that. Okay. Mapping out the graph. So cosecant, we don't have to think too hard about. We'll be able to fit it on there. I just want to make sure the phase shift isn't going to be a problem. The period is 2 pi, and we're moving to pi over 4. Yeah, we'll be fine. So we'll just do 4 to the right and left like we normally do. Vertical shift is down 7, though, so I'm going to start pretty high up here. Okay, so we got 1, 2, 3, 4. 1, 2, 3, 4. Then down 7. 1, 2, 3, 4, 5, 6, 7. I probably should have spaced those out a little more, but it's fine. Negative 1. Okay. Now our intervals are pi over 2. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi, as it should be. That is our period. Negatives. Okay. Phase shift is through pi over 4. Now notice it is missing from the graph. So if you have trouble locating where to put it, remember this is like 1/4 pi. So it'll go between 0 and 1/2 pi. So it'll go here. So we have to add that extra value. So this is pi over 4. And then this is our phase shift. So this is going to be a tweener. And then our vertical shift is down 7. And I totally forgot to also think about the fact an amplitude is 1. So I do need one more notch, because I'm going to go up and down 1 from there. Okay. And then my vertical shift down 7. So we're going to go here. And that is our new midline. So our new origin, our new starting point is here. Okay, let's start graphing some points. Cosecant is sine. So sine starts at the origin, so we're going to put our first point there. Now remember, tweeners land, hence the term, in between. So make sure you're landing in between on the intervals. So if it helps, you can carry these x values, these notches down here, just to make sure that you are staying in between them as you graph. I'll give it an extra helpful visual, especially since I'm all the way down here. Okay, so starting at sine, not reflected, so we're going to go up for the next point, and we only go up 1 because our amplitude is 1. So up 1, midline, down 1 for our minimum, which is -8, and then midline. And then back the other direction. Yeah. So, hang on, let me carry these down, or I will definitely mess this part up. Okay. So, we got to land over here. So midline, and then we max to the right, so minimum to the left. So we're going to be down here on the -8. And then midline. And then maximum and midline. Yeah, that looks pretty good. I always get nervous for some reason when we get to the y-axis. I don't know why this trips me up, but it really does. So I have to be extra careful, personally. Okay, let's start filling in the parts of the graph. Midline points get asymptotes. So our phase shift is also an asymptote here. Okay, midline points got asymptotes. And then our U's. Maxes go up, and these are going to go up quite a ways. Okay, we got 2 of those. And then mins go down. Okay, so there's our graph. Fun part, our asymptotes landed in between because of the tweeners. So I have to now go through and relabel what these values are so that I can write out my domain. The good news is we've already identified what the unit is. These are in fourths because this one was pi/4. So just kind of think about it that way. So I'm going to count and then label as I go. I need this space down here to make my domain, so I'm not going to write these at the bottom. That would be my preferred place to put them. So I'm going to kind of write in red over those notches, if you will. So this is 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4. This is 5 pi/4. 6 pi/4, 7 pi/4, 8 pi/4. This is 9 pi/4. And then we can kind of compare. So, can we? Sorry, I'm getting lost where I'm at. Okay. Now, I'm just going to count. That'll help me. Negative pi/4, negative 2 pi/4. This is negative 3 pi/4. Negative 4 pi/4, negative 5 pi/4, negative 6 pi/4, negative 7 pi/4. So there are my domain values that I need in order to create my domain. Okay. Domain. Asymptote to asymptote. Negative 7 pi/4. to negative 3 pi over 4, union, negative 3 pi over 4 to positive pi over 4, positive pi over 4 to 5 pi over 4, and lastly 5 pi over 4 to 9 pi over 4. All right, range. Negative infinity up to our minimum value of negative 8. Bracket, since the negative 8 is included. Union, jump up to our maximum value of negative 6, and then that goes to infinity. So bracket negative 6 to infinity. There's my full graph. That was a bit involved. 3 more. 13. Y equals 3 secant 8 x plus pi over 2 plus 3. Info. This is still the amplitude here. It is 3, period. Almost messed that up. Secant, we use 2 pi over b. So, b here, if we look in front of the x, it's a 1, so we go in front of the parentheses and we have an 8. So it's 2 pi over 8, which is pi over 4. So the period this time is pi over 4. Interval, pi over 4 over 4, that's pi over 16. Phase shift. So we have x plus pi over 2 equals 0, parentheses equal to 0. If you solve, you get x equals negative pi over 2. And then vertical shift plus 3. Graph, I'm going to think about this for a minute. Our phase shift is left pi over 2, and our period is pi over 4, which is half of pi over 2. So once again, I'm going to need to go out 2 full periods to get to this phase shift. So I'm going to do, did I do on the last graph or the graph before? This is the graph before it. Number 11, where I went out 2 full periods to the left to hit that phase shift, and then I just did 8 points to the left and then none to the right. That's exactly what I'm going to do here. Okay. And then I got a vertical shift of plus 3, amplitude of 3. So I'm going to need a lot of space on the top half of the y-axis. So I'm going to start kind of low. And I need 8 values here. All right, and then vertical shift is plus 3, so I got 1, 2, 3 is my vertical shift. And then my amplitude is 3, so I'm going to go up 3 more and then down 3 to hit the x-axis. 4, 5, and 6. At this point, I'm just going to start labeling the points I'm actually going to be using, to be completely honest, on the y-axis. Okay, and then interval is pi over 16. So we've got, these are all going to be negative. 1 pi over 16. 2 pi over 16 is negative pi over 8. Negative 3 pi over 16. Negative 4 pi over 16 is negative pi over 4. As it should be, that's my period, and I'm 4 points out. Negative 5 pi over 16. Negative 6 pi over 16 is negative 3 pi over 8. Negative 7 pi over 16. Negative 8 pi over 16 is negative pi over 2. 2 periods, my phase shift. So that's why I needed to do that. Okay. Phase shift is all the way out here. My vertical shift is through 3. Okay. My new origin is where they cross. And then secant is cosine. No reflection or anything here, so we can proceed as normal. Cosine starts at the maximum, so I'm going to go up 3. If I'm at 3, I should be up at 6, which is what I have. So that's my maximum point. And then from the maximum, we go down to the midline for the next interval. And then we go down 3 for the next interval because of our minimum. 3, so we should be hitting the x-axis. And then we go back. So next interval is at the midline. Next interval is at the maximum. Next interval is at the midline. Next interval is at the minimum. Next interval is at the midline. Yep, looks good to me. And let me go one more to get an extra 8th point to the right, just to fully make this feel complete. There we go. Okay. Asymptotes through the midline points. Okay, asymptotes through the midline, and then maxes get those u's going up. Stop that there. And then minimum, I've only got 2 of them. They go down. Oh, my phase shift. I was like, I feel like I'm missing something. My phase shift point is a maximum as well, so it's going to go up. So I'll draw that half as well. Okay, there's my completed graph. And then domain and range, again, I'm going to just look at the asymptotes portions for the domain since the other asymptote isn't drawn. So my first asymptote is at negative 7 pi over 16. And that takes me to negative 5 pi over 16, union. Pick back up at negative 5 pi over 16. We go to negative 3 pi over 16, union. Negative 3 pi over 16 to negative pi over 16. Yes, good. And I can stop there for the domain. The range. Range, we have negative infinity up to our minimum value of 0, bracket, union, bracket, up to our max of 6, and then up to infinity. There's my range. There is my completed problem. 2 more. Number 14. This one looks a little more tame, I hope. Y equals tangent of 2x minus pi. Info. Tangent, this is called the stretch. A is 1, no reflection. Period. Tangent, this is pi over b. pi over b, go to the x in front of it, we have a 2. Pi over 2. Interval, pi over 2 over 4, that gives me pi over 8. Phase shift. Set the portion inside parentheses equal to 0. Add pi over. And that gives us 2x equals positive pi. Divide by 2, x equals pi over 2. This would just keep focusing. That would help. Yes. Okay. X equals pi over 2. All right. And then, thankfully, we don't have a vertical shift because that detail is kind of getting lost at the bottom here. So I don't have to worry about that. Okay. Graph. Let's think about our intervals. Our period is pi over 2 and our phase shift is pi over 2. So this is shifting over one full period. Okay. So since tangent sits in the middle of the interval, I'm going to need 2 extra points to the right to be able to fully graph it. So I'm going to go 6 to the right and then 4 to the left. I won't use all 4 of those to the left, but just so I have it. No vertical shift. For the first time in forever, it feels like. So I can go in the middle here. No worries. Okay, so I need 6. 1, 2, 3, 4, 5, 6. Y-axis. 1, 2, 3, 4. Our stretch is 1, so I don't need to go that far up and down here. 1 and -1. Intervals of pi over 8. 1 pi over 8, 2 pi over 8 is pi over 4, 3 pi over 8, 4 pi over 8 is pi over 2, as it should be. I'm now at the period and the phase shift. 2 more, 3, 4, 5 pi over 8, 6 pi over 8 is 3 pi over 4. Okay, and then the negatives. No vertical shift. Phase shift is through pi over 2. So this is my new starting point. Tangent starts in the with its middle point on that origin, so that's going to sit here. And then tangent has a disco right, so to the right we're going to go up to that maximum. Not maximum, but like our up point, if you will, up by A, which is 1. And then to the left, we're going to go down by A to create that disco right shape. Asymptotes, if I go out 1 more to the left and the right. Now I can create that disco right shape. And now I just got to make another one of those. So I'm going to go to the right, copy and paste my points. Here's my asymptote. Next is my up point. Next is my midline point. And then next is my down 1 point, and then an asymptote. And then disco right. And then I can stop there. I've graphed 2 periods now. Domain and range. Range is always the infinities on tangent and cotangent, so I'll fill that in. Domain asymptote to asymptote. I'll have 2 intervals here. Negative pi over 4 to pi over 4. Union pi over 4 to 3 pi over 4. Okay, I liked that one. It was very nice compared to some of the other ones. All right, our last problem, number 15. Y equals -3 secant 2x plus pi plus 1. Okay, info. Secant, so this is an amplitude. Oh, and of course our last one would be a reflection. So remember, this has to be positive when we write it down, so it's 3. And then we note the reflection. Period. Secant, so we're back to 2 pi over b. So we have 2 pi over, our b value is in front of the x, it's 2. So pi. Interval, well, it's just pi over 4. So at least it's an easy interval to work with. Interval phase shift. We have the parentheses, 2x plus 5, equal to 0. Subtract the pi. We have 2x equals negative pi. Divide by 2. X equals negative pi over 2. And lastly, we do have a vertical shift of plus 1. All right, let's figure out how the graph is going to look. So I can pretty much stick with my trusted 4 to the left and the right as long as the phase shift doesn't go off the graph. My period is pi, and pi over 2 is less than that, so we're good. 4 to the left and right will work here. And vertical shift of plus 1. I'll drop a little lower than usual, not much, just to accommodate for that. Okay. Okay, so we need 1, 2, 3, 4. 1, 2, 3, 4. Secant and cosecant are nice. 4 to the left and right works pretty much every time. It's tangent and cotangent you got to really think about. Okay, my intervals are pi over 4. So I've got 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, and then 4 pi over 4 is just pi, as it should be. That's my period. Negatives. Okay. And then my phase shift is through negative pi over 2. I should go down a little bit more. Okay. Vertical shift is plus 1. And then our amplitude is 3, so I'm going to need to go up 3 more. And that's going to leave me at 4. And then I'll need to go down 3 for my minimum. So that's going to leave me at negative 2. Yes. Okay, and then my vertical shift again was at plus 1, so I'm going to go through that. Okay. Midline. And vertical shift of plus 1. Alrighty, graph. Where they cross is my new origin. And then this is secant, which is cosine. Now cosine typically starts up at the maximum, but I want to go check my amplitude up 3. I see it's a reflection, so I'm actually going to go down 3, which is negative 2, which is what I have marked. So I'm going to start at a minimum instead of a maximum. And then I'm going to proceed like usual. So I'm going to go to the midline next. And then to the maximum, which is at 4. And then back to the midline. And then down to the minimum. And then back to the midline. And then back up to the maximum. Yep. And then to the left, I'm going to follow the same pattern. So minimum, again, I'm going to go back up to the midline. And then up to a maximum to finish my graph. All right, filling in all the extra details. Midline points get asymptotes. Okay. So all midline points got asymptotes, and then max points are going to get the u's going up. And then minimums are going to go down. Yep, I think I've got everything filled out. All right, so here's my completed graph. Domain and range. Both are special, so you got to pay close attention. Domain, asymptote to asymptote. Negative 3 pi over 4 to negative pi over 4. Union. Negative pi over 4 to pi over 4. Union, pi over 4 to 3 pi over 4. Yep, got them all. Okay. And then the range, negative infinity up to our minimum value of negative 2 with a bracket. Union, bracket, jump up to our maximum value of 4, and then we go up to positive infinity. And there is my completed number 15. And that is all of the problems on the study guide 15 graphs. All right, I hope that this video has been helpful to anyone who's watched it. If you've watched part of the video, all of the video, I appreciate you nonetheless for at least taking the time to check out some of these problems and hopefully get a better understanding of how these work. Make sure your answers are right, what have you. If you have any questions that this video did not answer, feel free to reach out to me via email or see me in person. Otherwise, I will see you guys later. Bye.